Hello, in this video I'll be solving a question that was set and examined in the year 2025, the month of May. So this is May, June 2025. This is M1. Now this question is on momentum and impulse. It's part of the topic of videos that I'm recording. Now, you've been presented with the two particles, that is P and Q, with the masses km and 3m respectively, each moving with a velocity, an initial velocity, or initial velocity is 5u and 2u respectively. And then you're told that these particles collide directly. And then we are being told that the direction of motion is unchanged. I think from this statement that we're having over here, that's very important. And then immediately after the collision, the speed of Q is v, so we can just say vq equals to v, and the initial velocity of P, I think it was already provided in the question, the final velocity I mean, sorry, so it's basically 2u. Now we already have a uq, that's the initial velocity of Q, that is 2u, and up, which is 5u. Now the impulse exerted on Q by P is 4.5 mu. So the impulse on Q will be the same as the mass of Q multiplied by the final velocity of Q minus initial velocity of Q. Now, what happens? We have 4.5 mu, which was provided in the question, which is equal to mass of Q, that is 3m, into bracket vq, which is v, then minus uq, which is 2u. Dividing both sides by 3m gives us 1.5u, which is equal to v minus 2u. And this gives you v as 1.5u plus 2u. I'm going to take this to the other side, and v is equal to 3.5u, and that is the expected solution for the first part of this question. Yes. Now the second part, which is part B, we are supposed to find the value of k. One thing that you have to know, this question examines Newton's third law of motion. Now, according to Newton's third law of motion, if P strikes Q, Q will exert the same force back to P, but in the opposite direction. So this means that the impulse on Q would be the same as the negative impulse on P. And we already have the impulse on Q, which is m, which should be the same as negative impulse on P, which is given by the mass of P, which you already have it in the question as km, into bracket the final velocity of P, analysis up there, which is 2u, minus initial velocity, which is 5u. Now this one gives us 4.5 mu, which is the same as what? Negative km times negative 3u. When you do 2u minus 5u, you get negative 3u. So now what have 0.5 mu should be the same as 3 kmu. So let's divide both sides by 3 mu. This one gives us the value of k as 1.5. This is the expected solution. So in case you don't know how we arrive at this, we're cancelling out everything. This is 1.5, u also cancels u, and that's the answer.